All right, so the title of this is Solving Systems of Equations by Graphing and Substitution, but today's only graphing because substitution's in the back, which you don't have, which is fine. We're going to do this by hand to talk about a couple things. It's going to be quick and painless. But then we're also going to, as we go through the system stuff the next week or so, we are going to look at how to handle it on the calculator, like the yellow calculator itself, and Desmos. Because remember, Desmos you can use on SAT. And yes, we're focusing on SAT a lot right now because SAT is October 8th, because I know you would ask me that. It's way earlier than it usually is. It's usually like the 23rd-ish. But because we're doing it on the 8th, I looked it up, and you should have your scores by the 23rd. So that's a pretty good turnaround there. But and then, you know, for this class, for me, I don't really care what we use, but for you, for college algebra next semester, I would almost guarantee that Desmos is not going to be an option because it doesn't work with their lockdown browsers. I don't think they're necessarily anti-Desmos. I can't even guarantee, close your computer. I can't even guarantee that you will get to use a calculator, but it being online anytime, I think it's maybe kind of hard for them to police whether or not you do. And so 2 different professors last year told me that they allow their high school students, their dual credit students, to use whatever the school allows them to use. So that's why, hence those yellow calculators, but not Desmos. So anyway, all right, so let's talk about, before we even get into this stuff, let's talk about 2 lines that some of us get mixed up a lot, okay? If you have just basic horizontal or vertical lines, one of them is an x equals line, one of them is a y equals line, and we need to know which is which and how that works, okay? So, a horizontal line. Do we think it is a y equals or an x equals? Y equals. All right. This one is y equals, so this will be like y equals 3, and this will be like x equals 3. All right. You also need to know the difference between the words vertical and horizontal can be very helpful for you. Horizontal is like the horizon. Vertical is like I'm vertical right now. I'm standing. Okay, so just make sure you know the difference between the two. Then I'm going to show you a little something Miss Ludicky showed me a few years ago. If you write a lowercase cursive y, and I know y'all really didn't even learn cursive, but you can do that. So write the y like that, the best you can. Then turn your paper upside down. And what does it look like? An H. So if I rotate this around, I get an H for horizontal. Okay? Y equals is horizontal. That's one way you can keep it straight if you get it mixed up in your head. Now, if you have an X and you turn that upside down, what does it look like? An X, right? But if you do this, it's a V. Okay? X equals is vertical, Y equals is horizontal. Don't get those mixed up. Those are easy, important things that we can get right. Okay? We good on those? All right. So let's talk about what a system of equations is. It is just 2 or more equations with 2 or more variables. Okay? 2 or more equations with 2 or more variables. 2 equations, if I have 2 variables, I have to have at least 2 equations. If I have 3 variables, I have to have at least 3 equations, and so forth and so on. Okay? And they don't all have to be lines. And anything you've done so far has probably all been lines. There were a couple questions, or maybe at least one on that green packet, where you had like a quadratic in a line, but you could have used Desmos. We're going to, again, go look at all those, make sure we know how to get 100% of those right on everything we do. But it's also good, even when you get to, oh, look, my lines are already here. Huh. That's funny. I guess I erased it, but whatever. I erased it, but the lines themselves are still there. I'm sorry, but it's good to know how to do things by hand as well. All right, so if I have one solution to a system, it would look something like this. There's one solution. The solution is where they intersect. What do they have in common? Okay. If I have no solution, it looks like this. How are those lines related? Parallel. Very good. Do we remember how to label the lines themselves that they're parallel? Anybody remember? Remember the little arrows like that? Yeah, because if it's on there for us, it's important that we know that that means parallel, so we know what the heck they're trying to say to us. If it has infinite solutions, should be an S on there, infinite solutions, then if I graph a line and then I graph the second line right on top of it, it's literally just the same line. The equation might look a little bit different depending on how it's written, but that's why it's infinitely many, because they share every single point. All right, everybody good? Now we're going to graph a couple lines. Your ID, which is supposed to be around your neck, makes a great straight edge. So if I look at number 1, are these in a form that makes it pretty easy to graph? Yes, I think so. This is in y equals mx plus b. So what does that -6 represent? The y-intercept. Very good. So I'm going to go to -6. I'm going to make a point. Okay. And then my slope is -5/3. So it's rise over run. I'm from here. I'm going to go up 5 and go, since it's negative, go to the left 3. You can go down and to the right, but then you're off the grid. So one thing I've never understood is they say to you rise over run 1,000 million times, but then for whatever reason, for negative, they tell you to go down, and that's not rise over run. So if you think about it, if you always rise, run to the right if it's positive, left if it's negative. Okay, and then there's your line. Okay, so go ahead and graph your other line. We've got your y-intercept at 5, and then your slope is 1/6, up 1/6, measure line. And then, since my lines were still there, this is what happened to me earlier. I didn't make my green line long enough. That might happen to you sometimes. You just put your straight edge back down there and extend it a little bit. Right there. And then this is where they intersect. That is my solution. I have an x value and a y value. And unless your answer is in context, meaning like I was looking for how much the books are and how much the drinks are or whatever, then it's an ordered pair. So that point is -6, 4. Okay. Everybody with me okay? Questions? All right. Now let's look at number 2. Are these in a good form to graph? Not necessarily. What would you do if you wanted to graph this? What would your go to? Z equal to y? Okay, so, or y equals, yeah. So let me show you something different on the first one though, just because we could totally do that. There's absolutely nothing wrong with it. But this is called standard form. And in standard form, so it's like ax plus by equals c. To get my x-intercept, it's when y is 0, and to get my y-intercept is when x is 0. So if y is 0, that means basically this term I can just ignore, right? Because that would 0 out if I substituted 0 for y. So that would give me 6x equals -45. And then I can divide both sides by 6. Those cancel out. This does, I should have done the other one because this one doesn't come out nicely. I get x equals, that'd be -15/2. Right? So that's -7.5. And that's my x-intercept. I can go plot that right there. Then to get my y-intercept, that's when x is 0. So that's zeroed out. And I would have -5y equals -45. And then that means y would equal what? 9. And that's my y-intercept. So that's how to graph it with the intercepts. Again, just to show you that there's a different way to do things. Solving for y is totally fine. Not a problem at all. But I want you to try to do this one the same way. Oops. Do it using the intercepts just to be different here. I won't make you necessarily do that on your assignment, but and in this case, they end up being the same number, but they mean different things. I got a -2 for x and a -2 for y. If I had solved for y, just to say it, because now I'm regretting a little bit not doing it at all. If I was going to take this one and solve it for y, I'll just do it down here. That would give me -5y equals -6x minus 45. And then make sure when you do that, the reason I did that one first is we were going to solve this one for y and then do this one this way, but those came out to be the same. I didn't want that to confuse you. Here, then you have to make sure you divide every single term by that -5. That's a mistake that happens sometimes too. So lots of things that we could do weird here. So I get y equals 6/5 x plus 9. We can solve for y, right? If I was to plot that, I go to 9 and then up 6 over 5, but I can't go up 6, right? But I can go down 6, and then I have to know which way that the positive points, right? And to the left 5, and I end up right there. So see how I'd get the same line either way? Whatever makes the most sense to you. And then my answer here is -5, 3. Okay. What questions do you have? Y'all can handle this, right? Old business, you can graph. Okay. So I'm going to give you your assignment. I want you, there's literally just 2, just like we just did. I want you to graph them right now, be done with them, and then we're going to do something else with them. Okay, so we've graphed them by hand, which is an important thing to be able to do. We're going to take these same 2 equations and we're going to graph them in our calculator. So turn your calculator on. And then this is the part that a lot of people missed this morning, and I probably did just gloss over it because, again, I'm kind of assuming you've used these and it didn't occur to me. So mine looks just a little bit different than yours. I mean, it's skinnier or whatever, but up at the top, and your little buttons up there are like long and skinny, or kind of curved at the top, or in the gray part. You see this y equals, you need to hit y equals so your screen looks like mine. See the y equals, it's one of the white or gray buttons up there. All right, so now we're going to type in these things. In these calculators, this is what is very important. Anytime you type in a fraction, put the fraction in parentheses, because sometimes it matters, sometimes it doesn't. You won't always know when. So since that is a 1/4, I open my parentheses, 1 divided by 4. Then to get x, everybody look up here. You got the second, you have this alpha key, right? You see this button right here? It's xt theta n. That gives you your x. Okay? And then plus 1. All right, we all get that typed in, okay? Yes, sir. Because it has to do with order of operations. And in this particular case, if I didn't put it in there, it would do 1 divided by 4 and then times x, which is really what we want. But there are some times where y'all type things into these calculators, and if you don't have them in parentheses, it's not doing what you think it's doing. So a safe thing to do, especially if you're not really experienced on these calculators, if you have a fraction, put it in parentheses, because we can't put it as like a vertical fraction, right? Since it's a slashy fraction, that is what we need to do to be safe. Okay, so just trust me on that. All right, so then we can hit enter to go down to y2. Now, listen very carefully here as well. we have negative x minus 9. Those are two different keys on here. The negative sign is down here by enter. So negative, and it's a little shorter, okay? Negative x, and then we want to subtract 9. You have to use the subtraction symbol, and you see how they look different? Because it's going to treat it differently, all right? So negative x minus 9. All right, we got that? Okay. Not trying to talk down to you, but I'm telling you, I know what kind of mistakes you make even when you know what you're doing on here, and I think most of you don't, and that's okay. But I want to make your life easier with these. And then, so now that we have those typed in, we all have them? We're all here? Okay, back up here on these little gray keys. Far right, you're going to hit graph. There are your lines in a very ancient looking pixelated view. Yeah, I know. Okay, here's what we're not doing. We're not guessing at it like we did on the paper, okay? We want the calculator to do stuff for us. And when we want the calculator on the graph to do something for it, we want it to calculate for us, right? So look back up at these keys. Do you see above the trace key in blue where it says calc? Okay, now let me ask you before we hit that. Yes, we're looking for the answer, but where on this graph is the answer? Where they intersect, exactly. So we're going to do second, because we want a blue. Are y'all listening? Second, and then trace, because that's really calc. And then we get this. Then what do we want? Intersect. 5. Okay, now get here and just pause for a second. Does it say my answer, right? But does everybody have something and it says first curve with a question mark? Yes. Oh, go to, wait. Okay, it's because this sign right here is a minus sign. You have to use that negative sign right there. So just hit negative, and now you're good. Okay? What's the difference between minus sign and negative sign? There is on these, yeah. Okay, and then do second trace. Okay. All right, so now listen what these calculators are asking you. This is not my answer. It's saying, you want me to find an intersection, but which two graphs do you want me to use? Well, there's only 2 on here, so you don't have to overthink it. It's flashing on this line. You go first curve, yep, that's it. Second curve, yep, that's it, because there's only 2 in there. Then it's going to ask you for a guess. Well, you know what? There's just 2 lines. Yeah, whatever your guess is. And you hit enter, and then bam, there's your answer. Okay? So really you just do second, trace, and then 5, and then enter, 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 and bam, there's your answer. Okay? And is that what we got on our paper? Yes. Okay. Now, I think the problem for some of you on the second one was solving for y in those lines. I don't know that it was the graphing part of it. So let's go back over here. Let's make sure that we all solved these for y correctly. So for this first one, all I'm going to do is divide. So that's going to give me y equals, let me just write this out like this. So I need to divide by -6. Oh, shoot, sorry, hang on. I'm dividing each one of these by a -6. So that's y equals -6 plus 1/6x, or 1/6x minus 6. That's fine too. Okay, we all okay with that? All right. So then the second one, I'm going to move that 4x. So -3y equal, oh my God. Why my brain and my hand don't agree, equals -4x minus 3. Then I divide every single thing by a -3. Those cancel out. Y equals a positive 4/3 x plus 1. Okay, those are our lines. We good with that? Okay. Now, whether you do a -6x plus, or -6 plus 1/6, or the other way around, what matters in the calculator, listen, is if I type it in this way, I have to use a negative sign. If I type it in this way, then I use the minus sign. They are different. It is very picky about that. Okay, so let's go type those in. So we're going to go back to y equals, and you're going to clear these out. Just clears right underneath the arrow keys. So I'll type it in with the x first. That's usually what we have anyway. So open my parentheses, 1 divided by 6 times x, and then minus 6. And then the next one, 4/3 x plus 1. Here's the good thing about Desmos. For Desmos, we don't have to put it in y equals. These calculators, you do. So we'll go back and look at that for Desmos too for SAT, but past SAT, we need to know how to do it this way. All right, so now I do what? Yeah, I want to graph it first, because here's the other thing. It's okay. Here's the other thing with these, which is not true on Desmos either. If I couldn't see the actual intersection point, then it wouldn't give me an answer. I'd have to zoom out so I could see it. In Desmos, you don't have to see it; it'll still give it to you. But whatever. Or not in Desmos. I guess those are the inspires, but I don't even want to talk about those. All right. So we're here now. We do second trace, right? What do we want? We want the intersection. 5, and then we just hit enter. Just hit enter until it gives you your answer. And it says intersection. And had I actually looked at this answer before I put this one on there, do you think I would have put it on there? Because none of y'all said it, but what did I hear all second period? 6, 7. Right. But hey, why was 6 afraid of 7? Because 7, 8, 9. See, that was around long before this stupid thing. Yeah. That doesn't even make any sense, but whatever. All right, but I'm proud of y'all for not saying it over and over again. Yes, sir. She got the wrong answer. You got to call her out. All right, I will come check hers in just a second. But are we all good on this? Y'all good? Okay.